Right, mechanics P1 International A level, October 2022. Question 7. So it's a new specification. We've got a table and a pulley, particle P, mass M, attached to one end, another particle Q, same mass, attached to the other end, passes over a small smooth pulley, edge of a table, particle Q is held at rest, and then P hangs vertically below the pulley with a string taut. And all line the same vertical plane. That means it's just still going straight down. It's not off to one side. So the forces are all either vertical or horizontal. Coefficient of friction between Q and the table is mu. Mu is less than 1. It's released from west. And the tension is kmg, it tells us. Find K in terms of mu. So there you go. So here's the forces. We've got mg, the weight of P acting straight down. Same at Q. It means there's a reaction from the table on Q. Now that's going to be equal to mg because they balance out, because it's just moving this way. There's no sort of vertical component of the resultant force. These two balance each other out. There's also some friction at the table. It's a rough table because the string's trying to pull it to the left, so the friction is acting to the right. Now that's going to be equal to mu times r, or mu times mg. There's also going to be tension in the string because that's what's pulling it along. It tells us that's kmg. Same at the other end. The weight of P is trying to pull it down, but the string's slowing it down. And it says Q accelerates this way and P accelerates straight down, and they're going to be the same acceleration because the string's inextensible. We're going to find K in terms of mu. So looking at the forces acting on P, equation of motion, mg is acting in the positive direction, the direction of the acceleration. So mg minus that t, or minus kmg, is equal to m times a. The forces at Q, well, we're just interested in the horizontal forces, not the vertical ones, because it's just moving this way. So we've got kmg minus the friction, or minus mu mg, I could write. So minus the friction is equal to m times a. And because they've got the same mass, I could put these two left-hand sides equal to each other. It means I can end up eliminating the m. So I've got mg minus kmg. That's equal to kmg minus the friction. And I'm going to use this and write the friction equals mu mg, kmg minus mu mg. And cancel out all these mg's now. So get rid of everything apart from the k and the mu. The 1 minus k is k minus mu. Take this minus k over and the mu over. So I'll have 2k is 1 plus mu, and k is 1/2 of 1 plus mu. It says Q is initially a distance d from the pulley. So this is a distance d. We're going to find in terms of dg and mu the time taken by Q to reach the pulley. So it's a SUVAC question now. I need to get the acceleration. I can do it from this equation because I know what k is now in terms of mu. But I can cancel out all these mg's now. The acceleration is just g minus kg, which is half g times 1 minus mu. When I substitute what k is in terms of mu into here, because it is in terms of dg and mu, I need to get rid of this k using what I found in part A. Put that in there, and g minus this simplifies down to this for the acceleration. And once the time taken to travel a distance d, so I'm going to use this one. I'm not interested in the v, the velocity as it hits the pulley. I've got an initial velocity of 0. T is the time I'm trying to find. That s is going to be the d, and then a half a, which is here. So, like I say, the u is 0 because it starts from rest. The d is the s, so half, and then a t squared. I'll just rearrange this. I'll put the 4 up there to make it 4d divided by g times 1 minus u, and do the square root. So I've got t squared. And there's the answer to part B. Describe what happens if mu is greater than or equal to 1. What happens then is that it just doesn't move because the mu's big enough to stop it moving altogether. If we think about it, if mu is bigger than 1, I've got a negative acceleration here, which just makes sense really, because it means it will be going backwards. So the string will be pulling it back up, and there's no force trying to make Q go to the right. You could think about this, the T. If mu is bigger than 1, this is bigger than 1 as well, which means the T is going to be bigger than mg, so it's pulling it upwards. It just doesn't make any sense at all. So it just means the friction is big enough to stop the whole thing moving altogether.